Technically speaking.
Welcome to Technically Speaking, where we help you increase your income through tech.
Right. So I'm not going to read this all. I do want you guys to read this on your own time, but I am going to skim through it, right? Because it is important to have a overall knowledge before we move on to packet tracer, right? So a network is a collection of devices, two or more, that share information between each other. Okay, so we already did the Googling of what a network is. Computers talking with each other. That's all it is. Okay. Now, these connections between each other, they can talk between wired cables or wirelessly, or wireless. We kind of know that already because most of us is probably not, hardwired into our modem or hardwired into our router. We probably are using a laptop that is on Wi-Fi. So most of the time, you probably go into your job and you probably have a desktop computer that's actually connected with the Ethernet port, all that good stuff. So you can do one or the other, right? You can, as long as you connect to the internet, you are talking. Even if you don't connect to the internet, you still can talk to a computer on your network, but we'll get into that. Now, a wired connection, a wired connection, the most common connection is referred to Ethernet. So when we say Ethernet cable or whatever Ethernet, I don't know how you guys probably heard it, but you probably heard it like Ethernet cable, Ethernet port. But we already know what it is. That's the you can say that's the cable that you plug into the wall, plug into the router, or plug into your computer, plug into your router or modem or something, right? Ethernet cable. So Ethernet is a technology consisting of data being transmitted through the wireless, through cables, right? Through wires or cables. So when we say Ethernet, that just means that it is technology that's being transmitted through these wires, right? I wish I had a cable with me right now, but the Ethernet cable, it has like, it has like 5 wires in it and it's interconnected and, it's electricity going through it and whatever. That technology is called Ethernet. Right now, Ethernet is actually governed. We have Ethernet police. They're called the IEEE. They are the Institute of Electrical and Electronic Engineers. Okay, we call them the Internet police, right? They tell us what we can and cannot do on the internet, right? So IEEE, they gives us the standard. Now, the standard of Ethernet is on a document called 802.3. So you're going to hear that a lot. They're going to say, hey, 802.3. You're going to hear that verbiage a lot in the field. That means Ethernet, right? So that's important to know. That's actually going to be on the exam. So take that down. This tells you a little bit more about IEEE. And it's telling you that it's an association, right? They're dedicated to advancing innovation and technology excellence for the benefit of humanity. Right, a whole bunch of that. So you can read that. I even brought you a nice little link so you can kind of know who IEEE are. I just call them the police because they are the internet police, right? They tell you what you can and cannot do on the internet, right? Wired or wirelessly. Wired is 802.3. Wirelessly, right? The IEEE regulates the wireless technology via a document called 802.11. So that document is telling you how we're going to govern wireless connection in the world, right? So they may say, like you can see, a wireless connection allows devices to connect to each other, but just over radio waves instead of physical cables. So they kind of tell you which radio waves you should be on, which radio waves is best to be on, how many channels you should have on each radio wave. The IEEE tells you all of that, and you have to abide by it. Or, your network's going to get shut down. So as an architect, we have to understand this document. I'm not going to go into it, but I suggest you remember that 802.11 equals wireless and 802.3 equals wired. Okay. If you remember that, then cool. All the other words that's asking the question, at least you know that 802.3 means Ethernet and 802.11 means wireless. So whatever question they form, you already know what, what I'm saying? They kind of go hand in hand. So going in, right, a simple network, right? For instance, a simple network is what we're on, like in our home office. We're probably at home right now. And that's our network that we're on. That's our local area network that we're on. We have our computer And whether that computer is a laptop or a desktop, we have that computer that has a NIC card built in. So we're right here. If you have a network interface card built in, so we're talking right now, we're clearly talking via the internet because you wouldn't be able to hear me. I wouldn't be able to hear you if we weren't. That means that your laptop or your desktop has a NIC card in it, a network interface card. It's just a card that allows your computer to actually get on the network, on the internet, and talk to people outside of your network, right? If your laptop or desktop does not have a NIC card, then nothing's gonna happen. You're gonna play solitary on it. That's what you're gonna do. But what I definitely well, I was gonna say how to build a network because this was my first document. So I definitely had a video on how to build a computer. I actually went through some type of like internship to where I was an IT generalist and we would fix computers, we would re-image them. So I worked in a call center and a computer was messed up. I would go get that computer, bring it to the IT room, open that computer up and check its components. Right now, since I was an intern, it was more of a learning environment. So we would literally just get computers, open them up, take them apart, or the mentor would take them apart and then say, hey, put the components back together. So I knew how to put the motherboard in, the SATA cables, add it to the CD-ROM, add the power cable, the CPU, all of that. I put all that together and even reseat the CPU, like I said, and yeah, get it back up and working. Then put software on it, which would be Windows, of course, and get it up and running. Put the necessary applications on there because the call center was big. It was like Walmart, Netflix, all these different things. So I would put proprietary applications, and it was pretty cool. But what I did find out was that the NIC card is definitely important. And when I got to networking, I'm like, oh, that's what that was. Because again, it was some really quick internship that lasted all of like a month, but I did learn. And when I came to learning computer networking, it started all to make sense of why I was doing the things I was doing. So anyway, just to go back to what we was talking about, I do have a video I may share, it may not, is old, but if you want to learn how to build a computer, we definitely can. I have an old computer. We can just, hop open the Zoom and I can show you guys how to build one. All right. So from the computer, got your NIC card. So now you can get on the network. So from the computer, and you can do a wired connection or a wireless connection, but let's talk about a wired. You have your Ethernet cable, and your cable is going to go from the back of your computer to the router or modem or Wi-Fi box, whatever you want to call it. And if you're using wireless, obviously you don't need a cable, clearly. So it's connected. Now on your computer, you definitely, even though you're connected to the internet, you still have to have some type of operating system in order to navigate. The operating system can be anything. Like I said, Apple, Android, Windows, Linux, whatever you are comfortable with. Most of the time, we're comfortable with Windows. I'm comfortable with Windows. Like I said, I'm an Apple hater, so whatever. If you like Apple, big ups to you. Now, cool. So we have the software, and then we can browse the internet. We can do all things because it's a good, good GUI, which is graphic user interface. So it's good user interface, especially Windows, Mac, easier than Linux and all your other operating systems. Now we have that on a computer. We have all that. Now we can access. Now we could talk outside of our network. Now let's talk about networks, right? These are the different types of networks. We have what's called a PAN, personal area network. Now it is what it sounds like. It's just personal. It's just a type of network that is managed by one person and usually found in your residence, like your home. So a PAN includes your computer, your modem, and your mobile phone or your tablet. So small businesses can be PANs. We're PANs right now. You're probably just in your house, at your computer. So that's a PAN. Next, we have a local area network, a LAN. It connects a group of devices together, right? But across short distances. So it's between buildings or, just something in close distances. So probably like something that's managed by like an enterprise. So maybe T-Mobile has an office here in Houston, and they have like two buildings, one on the north side of Houston, one on the south side, so that'll be like a LAN. That'll be their two LANs. And, maybe they'll have something in California. That'll be their LANs, right? Or even they can have a wireless LAN, right? If you see here, a wireless local area network, it's just like a LAN, but it's wireless. Instead of connecting 802.3, we're going to connect 802.11, right? Wirelessly. Then we have a campus. Hold on. Scrolling too fast. We have a campus area network, a CAN, right? It's another network, straightforward, right? It's just a network that is designed for campus, designed for school districts like universities. So they are like LANs, but a little larger because it's university. So when you see CAN, that means that is typically a school, right? Some type of school. We have a MAN, a metropolitan area network, right? This is both a hybrid of both a LAN and a WAN. A WAN is a wide area network, right? A LAN collects a LAN basically connects multiple LANs together, as you can see down here. A LAN is larger. So, like I said, T-Mobile. T-Mobile has an office in California and in Houston and in New York. And all of that is they can all speak to each other in a private network. That's their WAN. That's their wide area network because they have to talk far from each other, right? Maybe there's an office in Japan at T-Mobile. You know, we still can talk to them in our own private network because we're on our own WAN. And we would get this from a service provider. So I did work at T-Mobile. And when I did work there, our service provider was some of our on our own network because, I mean, we are a telecommunications company, but we also have another service provider, which was bandwidth. And we use their network to piggyback off of the towers so we can expand our network range and users can use our network. So we had our own private WANs that only we would communicate over. And that was, again, proprietary to our network, and it was a WAN, right? So remember, MAN is metropolitan. Metropolitan, a hybrid between a local and a WAN, right? More like a city town. When you think of a town getting together, maybe something like a court system. That's more like a MAN. And then we have our WAN. Like I said, it's to connect multiple LANs together. And then we have a VPN, right? We should all be familiar with a VPN, a virtual private network, right? It's just for you to be able to mask your IP address when you are using the internet. It's really used for when you don't want your internet service provider to know what you're searching, right? It's more like a data protection. You want to protect your security because you don't want someone to, your internet service provider to be like, oh, well, you're looking up this or you're looking up that. Like, leave me alone. Now, as far as enterprise, obviously we use that because we are sharing files between each other. So there's no need to share that for the whole internet to see, especially if, let's take when I worked at T-Mobile, let's just say I'm sharing out financial reports. We don't need everyone to see that. So I need to get on the VPN so I can share that securely. So that's that. Now, these are a lot of different networks. I suggest you get familiar with them. The biggest ones are LAN, local area network, WAN, wide area network, and VPN, virtual private network. Those are the really big ones, right? We can throw in wireless local area network. We can throw that in because it's wirelessly. But like I said, you definitely want to kind of know the difference when somebody says a PAN or a MAN or a CAN. You kind of want to think about, okay, that's probably campus or something in that sort. But as far as the exam goes, they're going to talk about LANs and WANs and VPNs out the butt. So make sure you brush up on at least those ones for sure. Okay, so going on. So now we have these network types, right? We have these different networks, whether it's a small network like a PAN, getting a little larger like a LAN, or really big like a WAN. We have all these networks. Now these networks are classified into different types of topologies or architectures. That means that they are designed, they are set up a specific type of way. Now, a topology, let's look down here. A topology is the physical or logical, right? So it can either be physical or something that is logical, your mind, layout of a network in the terms of how it's linked with this data. So let's go in a little more. Let's go down a little more. So we have a topology. let's look at this topology right here. It's called a bus topology. It's a single communication line for data transmission. So that means that these lines right here, these circles are network equipment. They're going to represent some type of network equipment. These lines is going to represent a data connection. That's like, let's just say that's a cable, right? That's going to represent an Ethernet cable. So the topology is a physical or logical. So the bus topology either is going to be physical, meaning that a computer's right here, that's connected to another computer right here, that's connected to another computer. That is the architect. Or the bus topology can be logical, meaning that, hey, they may look like this. They may actually be they may be set up in a lab or in a room like this, where there's 3 computers, they have cables, and they're connected to this one equipment. But they send data in a straight line, right? They send data logically in a straight line to where one is one after another, right? So it may be this one go, that one go. Or maybe this one here, and then that one go here, that one go there. It just depending on, the way the data is going. But it doesn't necessarily mean that, this is not a bus because it's a logical layout or a physical layout. Again, it just depends on you as the architect. And if you're not the architect needs to explain that, right? Because we don't know what's in the architect head. But again, this is exactly, architecture. So let's look at another topology, a ring topology. Consists of devices that are arranged in a circle design. It's similar to a bus topology, but a closed loop. So it just keeps going and going and going. Data just flows all through these, right? So topologies are architectures. That is how it is laid out, physical or logical. That's how the network is laid out. So get familiar. We're not going to go through all of them. Topologies are important, but I would say it makes up like 2%. It's more fundamental. It's not like, they're going to have these questions on the quiz, but you should at least know what a topology is and know kind of a little bit about it. Like, okay, a bus, straight line. That's how I look at it. How does a bus go? A bus is just straight up and down. It's just, big. So boom, bus topology. Ring, what does a ring look like? It's circle. It's just a loop, right? There's no breaks in a ring. So automatically I'm thinking that the data just goes in a circle, right? So kind of, do that. Kind of look at it in that way. Now moving on, we have mesh topology. A mesh is just all the network devices just interconnected, as you can see right here. Very redundant, has availability. I can't get at that. And most important is, high cost, and it's complex to have all these devices interconnected. So, you may not see a mesh out there and nowadays, but hey, you may be the one to configure it. Who knows? But going on, topologies, can't stress it enough, can be logical or physical. It's just how the architect has laid it out. Now, when we're talking about going deeper into architects, because we talked about topologies, let's actually talk about architectures. There's really only 2 structures. So we have a 3-tiered structure and a 2-tiered structure. Let's look right here. So a 3-tiered structure is a core layer, a distribution layer, and an access layer. This is how our network is architected, right? We have our topology, which can be a physical or a logical, right? Now we have our architecture, which is how the data is actually going to flow. So we always have our access layer. Our access layer is always at the bottom. What is access layer? Access layer is any device that can connect to our network. It is the access to our network, period. Access layer. Distribution layer. Distribution layer is all about distributing, filtering, forwarding that data as fast as possible, right? Well, I wouldn't say as fast as possible, but it's definitely about filtering and forwarding, because now we need to see, do you belong here? Can you be here? What's going on? What's happening? For instance, someone has a computer, connects to the access layer, and decides that they're going to go to facebook.com, reddit.com, some type of social media site, which is banned. So once the distribution layer get it, they're going to be like, whoa, no. You're going to get an error, 404 or something, 502. I don't know. You're going to get an error So that's what the distribution layer is for, to filter forward. And then the core layer, it's just to send the data as fast as possible to whatever it needs to go, which is most likely outside of the network, right? Most of the time, this is like out when you see the core layer, at the top of the core layer is like a cloud, which represents the internet. So we're going to access the network by the access layer. Then our data is going to get to the distribution layer and say, where should you go? Where should you go? Do you want to go to finance department? Do you want to go out to Japan and talk to your vendors? Do you want to go talk to your mom? Like, what's happening? And then the core layer says, okay, let me send that out as fast as possible. Again, this is happening in a millisecond. This is like, you know, so moving on, right? That's the first architecture. The second architecture is called collapse architecture. It's for smaller networks. Maybe you don't need all that 3. You just need 2. You just need an access layer, access my network, and then the core and distribution can work together to filter forward and send it as fast as possible. That's for small networks because they don't have all that money to be having all them servers, all them routers. Just send this data, right? And I don't have a lot of data to go through my network because I'm a small business. So collapse architecture is for smaller networks. Please understand these 2 architecture types. You will be asked that on the exam. You'll be asked that, period, So you should know this. You should know what type of architecture is going on in, different networks. At least be able to talk to it, right? We will talk about this more and more. Don't think that this is the last time you're going to hear this. We're going to talk about this more and more. And you're going to start thinking like, oh, okay, I get it. Probably 3 weeks in, you're gonna be like, I remember what you said on day 1. That makes sense now. That's just how I go. I'm sorry that, you kind of get a little, it's like knowledge dump. And then you start to actually decode it later on. And that's just how it is because this course is like a 4-year course. It's like a 4-year degree, a computer science degree. This is what they teach low key. And we're about to learn this in 6 weeks. So it's definitely about to be a knowledge dump. It's basically about to be a lot of information overloading your brain. Honestly, if you're not sleeping, eating, and breathing this, then hey, I don't know what to say because you have to. This is a whole new language if you guys are not already familiar. But moving along. So this is network basics. Ending it, we're going to talk about cables specifically. There are 2 types of cables in a network, copper cables and fiber cables, right? Cables transmit data. Even though we work wirelessly, we love Wi-Fi, we got our phones, we got our tablets, we got our laptops, there's still cables in the network. You're connecting to a wireless modem to a Wi-Fi box that's connected via your Ethernet cable. So no matter what wireless you want to say, we still operate off cables. And those cables help us transmit data either in a copper way or a fiber way, right? So the cables, they transmit data through electricity, right? That's the most commonly used cable is the copper cable. And we call that a Ethernet cable, okay? If you take a look, it looks just like this, right? You see these little wires? This is exactly where the data, the electricity is being transmitted. It's transmitting ones and zeros, ones and zeros, ones and zeros, binary, because the computer only can read 0 and 1, 0 and 1, 0 and 1. So 0 is off, 1 is on. So they decode this. They say off, 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 on, off, on, off, off, on. And in our language, it's going to turn into, hey, mom, how are you? Or it may turn into, what is the link to the class, right? But for the computer, for the network cables, the Ethernet cables, the data that's being transmitted is that sentence or that paragraph in zeros and ones, zeros and ones. We will talk about that. We're actually going to get into that probably in the next lesson, depends on how far we get. But you'll definitely learn ones and zeros. You're going to talk ones and zeros, okay? So cables, copper cables. We have 3 types of copper cables. We have a straight through, a crossover, and a rollover, right? That means that the cables inside the wires, if you look in this picture, these wires inside this head is either straight, meaning that if you look at this diagram, they go from from left to right, or right to left, however you want to say, they're just straight. That's how the cables are configured or placed in that cable, or how the wires are placed in that cable. I don't know how I want to say it. Then we have our crossover cable. That means that, let me scroll down here so you kind of can see it. That means that in this same little area, the cables, the wires, because if you kind of can look a little bit, you can see that these wires are they're different, right? So these wires are crossed over. So one would actually go into 3-pin, right? The third pin over here will go into 1-pin. This is actually very vital that you actually know this information. This is on the exam. You should know this period, honestly, regardless if you take the exam or not. But for my exam people, you need to remember this. You need to know a straight through cable. That means that 1-pin connector A goes with connector B is 1 to 1, 2 to 2, 3 to 3, 4 to 4, right? And it's the connectors. That means that this is one side. Hold on, let me see. Let me see if I can get a cable for you guys. Hold on. Okay, I'm back. So I have a, hopefully, see, so boom. This will be side A, this will be side B. When you make cables, because one of my contracts I actually had to make Ethernet cables because we ran out, so I had to make them. So I have a video on that too. We're gonna make some cables. But anyway, you have two sides. You see that you have A and you have B. So this side, the pins are set up 1, 2, 3, 4, 5, 6, 7. That means that orange and white is 1, orange is 2, white and green is 3, and that's actually the colors in this pin. I can take this off and look at these colors, and they're actually set up like that. I can't really show y'all because whatever, but they're actually set up like that. And then crossover cable means that the orange one actually goes to the number 3 side, right? So again, it's just these wires inside of this connected. And the only way you can tell once you actually create these cables, because what you'll do is you'll probably get, like, in the office, they'll have some wires like this, that's probably like 600 feet long, and you'll take it, you'll cut enough of however long you want your cable to be, and then you will strip the ends. You'll get these little wires, you'll push them out. You'll put this RJ45, that's what this clear thing is called. This clear thing over the wires, it's called a RJ55. You'll put that on into whatever you want to make it, whether you want to do a straight through, a crossover, it's up to you, right? Or even a rollover, right? So for all my exam folks, I suggest take a little deep dive in that. If you want another like deep dive like session, I don't mind teaching that because it took me a minute, but once I was building Ethernet cables, I know this like the back of my hand. Now, rollover cables, they do the exact opposite of straight through cables, right? So they, instead of 1 being to 1, 1 is to 8, like it's just rolled over. That means that these cables on the inside are rolled. They're rolled. That's all that means, okay? So learn those 3. Learn those 3, I'm telling you. All right, so I even said as a network engineer, you may be tasked to create an Ethernet cable. So it's important that you understand the different types. Here's a cool video of a friend of mine creating an Ethernet cable link. And we were creating cables one time in my contract. It was really cool. And link, yeah, I don't have the link here. I was taking some of my videos out because they were kind of like a little low quality, but whatever. So keep going on with copper cables. With copper cables, they are, there's 3 types, right? We got the rollover, we got the straight through, we got the crossover. Okay, make sure you know the difference. Now, with those 3 types, those can either come in an STP, which is shielded twisted pair, or UTP, unshielded twisted pair, right? STP just means that there are shields around the cables, right? The little like full little full things around it, right? Little wrappers. Obviously unshielded means that it's just out in the open, right? Now, the shielded twisted pair usually cost more because they are going to stop any type of interference. So if you have a cable and maybe you like to twist it up, or maybe the cable is on the floor and you're walking over it. If it's unshielded, the cable is going to go, it's going to probably get weaker in the connection, right? But if it is shielded, then the cable will last longer, hence why it costs more. So in the network, you're definitely going to see more unshielded twisted pair. That's just because, it's always cost effective and they wonder why things don't work. But regardless, boom, that is something you should definitely know the difference between unshielded and shielded. You may have like a question or two on the CCNA about it, so know about it. Now, we're done with copper cables. Let's talk about fiber cables. Fiber cables, also known as fiber optic cables, which you may hear when you probably move into an apartment. They're probably like, oh, we have Wi-Fi speed, fiber optic cables, AT&T, Verizon, whatever. You're like, yeah, that means that data is being transmitted through light. So it's made up of like glass and plastic fibers that house light. So light shines through, and light is the carrier of the ones and zeros, right? And there's two types of fiber cables. We have single mode and multi-mode. Let's scroll down here. So single mode is a single strand of glass fiber that supports one mode of transmission. That means that it's going to support send or receive, right? It can run for a very long distance, and it's very expensive compared to like multi-mode, right? Multi-mode supports multiple modes of transmission, right? But they are used for smaller distances. So single mode can travel really far, but multi-mode can't travel that far. But it can do both transmissions, send and receive. So definitely understand the different types of fiber cables and know that fiber transmit data through light, right? Copper transmit data through electricity. So please know the difference, because that's like an easy question to get wrong. Like, don't get those questions wrong. We want to, get the easy questions right so we can kind of gamble on those hard questions. So when choosing the right cable for the job, you just have to know the specifics and what type of connection is required, right? So whether you're wiring an apartment complex for internet connection, fiber optic cables, or maybe what you use, right? Or if you're trying to connect the desktop computer to your router home, a copper cable would be the best choice, right? But just make sure you know that how data is being transmitted through these cables are through light, which is fiber, or electricity, which is copper. Okay, so that was basically a little rundown of the network basics and what it consists of. And again, that is in the Notion, so you guys can definitely review it a little more, go through the paragraphs and actually get an understanding of what's happening. What I don't have here, what is a network? Let me see, what is a network? Actually, I'm going to make it a different section. I'm going to put the network. I'm going to put something here. Let me see, add, or maybe I can do a page. Should I do a page? I don't know. Actually, yeah, I'm going to do a page. I'm going to say OSI versus TCP IP model. That's what we're going to start with, right? Because that is something we need to learn. So let's do a file. What type of file we're going to add? Choose a file. Let's do computer networking course. I think it's this one. I think I got two. I don't know why I have two in there. But regardless, we're moving on. Now before, let me pull that up here. All right. So we talked about network basics, what a network consists of, right? So now you should know what components create or make up a network. So if my computer wants to send your computer some information, if you want to talk to me, you know exactly what the components to have. You say, hey, you need a computer or some device that connects to the internet. You need some device that connects you to the internet, which is a router or a modem or something. You need operating system, whether that's an Android or a Mac, Apple, whatever. You know these things. An interface, a network interface card is in your computer. It's even in your phone, even your tablet. Like I said, if it connects to the internet. So you know all these things. So with learning the networks, let's actually discuss how data is actually transmitted through the network, right? Because it's transmitted in ones and zeros. But what we have is we have a model, which is called the OSI model, or older model, which is the TCP/IP model, which we'll go in. These are frameworks to understand how data is transmitted through the network, because we have to have some type of visual, some type of basic foundation of how I'm going to be able to send you good morning gorgeous, right? So how do we do that? Boom. Let's start with the OSI model. It's short for the Open System Interconnect. It is a model created by the International Organization for Standardization, the ISO, and yes, it should be, okay, I tried to make a little joke, but ISO is independent, right? It's not a government organization or anything. It's an independent organization, and they basically use this as a benchmark to model design and how we are going to troubleshoot, how we would troubleshoot networking issues. And it has 7 layers, and it's an up and down approach. So let's go to that approach. OSI layer, OSI models. We have 1, the physical layer, right? You can start from 7 to 1, or you can start from 1 to 7. Now, for me, I like to start at 1, right? It's 1. That's why I don't like to start at 7. And I like to start at 1 because it's the basics. It is the physical. It is how we're going to connect. So physical, number 1 is sending data on a physical wire. That's the physical layer. So the ones and zeros that transmit through copper or fiber, right? That's layer 1. That's the beginning of data. The second layer of data that's being transmitted through the network, right? So let me just give you a visual. I'm on the computer, I have my computer, and I decide to send an email. And the email says, whatever the email says, hello, how are you? And I want to send that to my mom. So I draft up my email, I pull up Gmail, I say, hey, how are you, mom? Put in her email address, and I click send. The first thing that happens is the data is going to go to the wires. Now it's going to go wirelessly because I'm on Wi-Fi, but in turn it's going to hit some type of wire. Okay, so once it hits the wire, it now hits a second layer in the network. And that second layer, let me go back real quick. Now that first layer, the example of a first layer is like a NIC cable or a cable, right? Or a NIC card or a cable, right? Ethernet cable, fiber cable, or a NIC card. That's an example of layer 1. So once it goes through that, you have layer 2. Layer 2 reads the MAC address from a data packet. So again, the data is in ones and zeros. Now it's in packets, it's in clusters of ones and zeros. Those clusters of ones and zeros will have something called a MAC address on it. The MAC address is a unique identifier of your computer, of your device. Every device has a MAC address. Your computer has a MAC address, your phone, your tablet, all those things. Those things have MAC addresses. It is unique. Everyone has a unique one. And MAC addresses have, I believe, the ending. I gotta look that up again. Either the beginning or the ending of the MAC address is proprietary to the manufacturer. So you can literally look at your MAC address, take it, Google it, and it'll tell you that, oh, it was made by Samsung or it was made by HP or something. I don't know, but that's the MAC address. Once it reads the MAC address, it says, where should I take this? What device does this packet go to? Then it hits to a network layer. And it says, okay, so we're going to take the MAC address, is going to go to this device. Now the network layer has come. It's network layer 3. Layer 3 is IP addressing. Again, we'll talk more about MAC. We'll talk more about IP addressing. This is just to get you familiar with this language. So it may be a little overwhelming or go over your head a little bit, but stay diligent. So we have a network layer, layer 3. It reaches the IP address in the form of a packet. So IP address is, 192.8.8.12, right? Everyone has their IP address. We can look in our terminal IP config and look at our IP address. We'll do that later, don't worry. But it has the IP address. So that means that it's routing over the internet. Data, MAC address means it's not on the internet yet. It's just in the network. Network means, oh, I'm trying to talk on the internet. Layer 4, transport, is either going to be TCP or UDP. It's the protocol on how do we transport this data, right? How do we transport it? Are we going to do TCP or UDP? TCP means that we're going to have a handshake. We're going to say, hey, do you want this data? And the other device is going to say, okay, yeah, I can take this data. All right, I'm about to give it to you. That's TCP. UDP is just like, I'm about to just give you this data and hope you get it. That's usually radio waves. Radio waves don't need a handshake or, any type of, hey, acknowledgement. Radio waves just blast out and whoever gets it, gets it. That's UDP. So you probably won't use UDP unless it's a broadcast, a public service announcement, you're sharing it to everybody. So that's the difference between that. So once we figure out, are we going to do TCP or UDP? Now we have to have a session, right? Session is layer 5. Session is exactly what it sounds like. It is the connection. When does the session start? When does the session end between two folks, right? Let's think of a YouTube video. YouTube video is 3 minutes. So the session going to start at, 0.000 and end at 3.0565 or whatever, that's the session. After layer 5, we have the presentation. How is the data now being viewed by the user? Is it encrypted or decrypted? So let's go all the way down to our physical one. What do? We were sending out an email. So now presentation is going to perform in some type of HTML format that actually comes out into a readable, hey, good morning, how are you, mom? Right? Now the seventh layer is application. That's just, again, where the end user is going to use it. And I just said the end user is going to use it on Gmail. So whether that's the Gmail app or gmail.com, that's the application. So as a network engineer, I only deal with 1 through 4, kinda, right? 1 through 4. 5, 6, and 7 is for software developers because this is all about how the look of it is. And usually as a network engineer, we kind of don't care about the look. We just care about, can this data get to where it belongs? We can use the dev team to figure out what it looks like for y'all. But we are, in this day and age, they like network engineers to know a little software development. So I suggest you get familiar with this whole layer. And again, it's a framework on how data is being transmitted. This whole thing, 1 through 7, happens in a millisecond. It happens like this. But all these things have to happen before it happens like this. We got to get it to the wire, reads the MAC address, reads the IP address. Is it TCP or UDP? What's the session? How long is it? Should I decrypt it or encrypt it? And then the application. That happens in a second, less than a second, half a second, right? And it's so many things, so many components. I think that's cool. I don't know if y'all think that's cool, but I think that is freaking cool. But yeah, moving along. So again, I'm not going to read all this. I want you guys to do your own reading, but it goes a little more into these layers so you can kind of see what's happening, right? Again, I'm not going to read all this. I would like you guys to do some reading. Now, we talked about TCP and UDP. TCP is a handshake. Synchronize and acknowledge, and then acknowledge, okay? So TCP, Transmission Control Protocol. That's what it stands for, Transmission Control Protocol. That means that we must have a 3-way handshake. So when you see 3-way handshake, think of TCP. When you see TCP, think of 3-way handshake. That means that I need to synchronize. I need to synchronize with you. Hey, I got this, right? And then I need an acknowledgement. Oh, you got that? You can send it to me. Okay, I'm about to send it to you 3 times. They call it the 3-way handshake. Whatever. You just need to know that that's TCP. Okay, so sync, act, and act from the sender to the receiver. And the opposite is UDP, User Datagram Protocol. Compared to TCP, is more about speed than reliability. Once you use UDP to transmit data, that means that you just care about it getting there as fast as possible. You don't care that it actually gets to where it needs to get. TCP means that no, it needs to get to that person. I don't care about I don't care about speed. It needs to be reliable, right? And again, UDP is used for like broadcasting and stuff. So no one's really going to use it because they want their data to go exactly where that data needs to be. So it don't require a handshake. UDP is just like, take it, take it, take it. I don't care if you don't catch it. So, that's cool in some sense. But, boom. UDP, broadcast, voice. I am specifically a voice network engineer. That means that I deal with voice over IP, internet protocol. So I literally take your analog voice, transmit it, digitize it into so it can broadcast over the internet instead of over radio waves, telephone waves, right? So that's
quick question for you. So when you say you do the voice, so like when you call the bank, well, are you talking about when you call the bank and then they be like, my voice is my password or whatever?
In a sense. So basically what I would do is first thing is when you call the bank, I am the one to ensure that that call gets to the bank's network, right? Because that 1-800 is going to be behind that bank's network. They're not going to use like some other network. They're probably going to use something that's proprietary to them because it's a bank and it's a corporation. So I make sure that the call can come through, your telephone call can actually come through the internet service provider or a public switch telephone network provider, which is telephone networks. I make sure it comes through that into our network. So when it gets into your network, your voice, your audio, you may hear IVR. I'm the one that scripts that IVR. So I will put into place, hello, thank you for calling, Chase Bank. Press 1 if you want to see your balance. Press 2. I'm going to set that up. And then once I set that up and you actually talk to a representative, I'm the one that facilitates you talking to the representative in a call center manner. So when you think of like customer service or when you think of just a company using their telephones, I'm the one that manages that type of network. I don't do too much of just the internet. I do like, the voice.
Oh, okay. Because yeah, it's so funny. I want to speak to a representative.
Exactly. I'm the one that's going to code that and she's going to say, hey,
representative. Yeah, okay.
Yeah.
Gotcha. Okay. It makes sense now.
So that's why I tell people to learn this information because I'm literally scripting out customer service representatives. So I'm literally, creating the intelligence to where you are out of a job if you are a customer service agent. Because now we don't need you to answer the phone. We have the robots and we can get that filter out and actually come to, probably the managers or someone else that can answer the phone. We don't need like low level or receptionists or things in that sort. So I really try to tell folks like you really need to kind of step out of customer service and learn more tech because customer service is really just honestly being depleted by robots. And why not be the one to learn how to create that robot, right? And that's what I do. I create robots. So
okay. I remember you. Well, I always remember you when I call. Like, oh, just do this.
Exactly. You're gonna get that call and be like, oh, okay. I know what she's saying. It's gonna start to get to you, and then boom, you just keep going through the course, and you're gonna understand how the mechanics work. And it's really cool. Every time I learn, it's like a pool, right? It just gets deeper and deeper. It's like the ocean. It gets deeper and deeper, and it's so much to learn. Like I'm not at all an expert in this. I am just someone that taught myself the CCNA. I got the exam first try, and I went and got a 6-figure job. So again, I'm not an expert, but I'm just showing you guys what I did.
Right. Okay.
So, yes.
Thank you.
Definitely, you're welcome for sure. Again, I want to just show you guys. I want to share the knowledge, and again, there's plenty of money. And honestly, every contract that I've been the only Black chick. I've been mostly the only chick, and then the only Black. And it's just like it's really hard to kind of talk to other folks that's not like me, So
Aww.
yeah, it gets lonely, but it's okay. It's all right because you guys are going to join me,
And is.
You guys are going to join me. Okay. But yeah, so just continue to go through these things here. Right now, just real quick on the TCP IP model, it is the transmission control protocol, right? Same as TCP, but IP means internet protocol. It's older than the OSI model and created by the Department of Defense, right? So they still use that. This is kind of the old standard. You can definitely use it. Again, most of the time, developers use the OSI model because it's broken down up here. But we usually just say, hey, we got the physical layer, the link layer, the network layer, the transport, and then all this other good stuff is for the developers, right? So that's kind of what we do as engineers. But we're starting to be, fancy, and we're starting to code as network engineers. So we kind of need this OSI model to know the session, the presentation, and the application. So it's the same thing. It's just how it's broken up, and the updated TCP has application all together with presentation and session. Again, it's just you need to know the difference, right? So please put that into your head, right? Putting it all together. Like I said, I kind of went through it a little bit, but we have the physical layer. That's that Ethernet port. Let's go ahead and get into the router, the modem. And then we go ahead into the data link layer. This is what a packet looks like. The packet's going to have the source MAC address and the destination MAC address. That means that who did it come from and where is it going? And it only can see what's next in line, not exactly who you're trying to send it to. Then you have the IP address of the source and the IP address of the destination. You also got the port number, right? Because we can have multiple IP addresses. So we need port numbers to separate us. And then we have the actual message. Hey, mom, right? So it's going to go up, up, up. And as you can see, it just adds on this layer. So review that. And then here's another diagram in case you guys want to kind of look more into it. You see, so this is sent through the cable, ones and zeros, ones and zeros. It is transmitted into a packet. This is what the packet looks like. MAC address, right? IP address, TCP, upper layer data, and frame check frequency, which is FCS. We'll get into that. Don't worry about that. All right. So what I learned with the with the layers was like, please do not throw sausage pizza away, right? So it's like, application, data, session, application, presentation, session, transmission, network, data, and physical. So please, yeah, that's kind of like something you kind of remind yourself, oh, what's the layers? Please don't throw sausage pizza away. So please is, the physical, the data, yeah. I mean, if you want to, learn it that way, you can. Honestly, I don't know if that helped me or not, but I threw it in there in case y'all, want to use it. So hey, may not work for me, may work for y'all. So
could you put it in the Discord, like what the how you remember it?
Honestly, how I remember it is like flashcards. I honestly just kept saying like, what's layer 2? Data link. I would be like, okay, what's layer 5? Session. I would just do flashcards like that. And that's kind of how I remembered it, because please don't throw sausage pizza away. That's cool, but no.
Okay. So. Yeah. Okay.
So yeah,
okay.
Flashcards. Okay. So and then just moving along, definitely port numbers. That's something that is on the exam, and that's something you should know, period. I deal with port numbers all the time, opening port numbers, closing port numbers, and these are port numbers, right? Port numbers are basically what the transmission protocol is going to use. Is either going to use TCP or UDP by that port number. So as an example, we should know HTTPS, right? Which HTTPS? Hypertext Transfer Protocol Secure. When you go to a website, what do? You say HTTPS ://www.google.com. Now you probably won't say all that, but that you'll see that as if it's a hyperlink or something. That is going to use TCP. That means that it needs to get to the destination. Ain't no just broadcasting. It's going to get there. And it's going to get there through a port number 443. So when you're in a network, when you're a network administrator, network engineer, and they say, hey, I can't access this website or something, make sure that port number 443 for HTTPS is open. All right. We'll get more into port numbers, no fret, but this is something you should kind of I ain't gonna say kind of, you definitely need to get into this, right? Port numbers are, we should know the well-known port numbers because they go up to 1,000, right? From 0 to 1023. Those are well-known port numbers. But you should at least know at least these. When they say SSH, secure shell, how we get in remotely to a virtual machine or something, we use TCP, port 22. No worries. We'll actually start SSHing into computers, and you're going to see that you're going to need port 22 to get in.